Alright, our next method is called substitution, and we're going to use this method, and it's going to be pretty rare, by the way, that we need this method. Most of the time we're going to be using our if-diff method, but we're going to use this method called substitution when the diff, or the derivative of the inner function, does not show up, or a part of it does not show up. And here's the big part: there are additional variables, okay, in the integral. So I'm sure you would agree that this x plus 1 is what we have been calling the inner function, right? Because it's usually going to be the base of that power. Well, notice how the derivative does not show up next to it, right? The derivative would just be 1, and we have this other term of x plus 2, which has an additional variable, right? There's another x in it. So this is totally different than the types of examples we saw before where the diff showed up next to it, or a multiple of the diff showed up next to it. So this technique involves us calling the inner function u, okay, and that's why it's called substitution. All right, we're going to be letting the inner function be represented by u, and then our goal, we're going to write this down, our goal is to rewrite this entire integral in terms of u. Okay, so that is our goal of this method called substitution. We're going to be substituting in all u's and getting rid of all the x's. So u is equal to x plus 1, and then from there we say that the derivative of u is just du. All right, technically it's times 1, but we just say du. And then, so think of that as we're taking the derivative of that left-hand side. Now, if we take the derivative of the right-hand side of this x plus 1, we know that the derivative of x is just going to be 1. The derivative of 1 is going to be 0. So we really have 1 times what we call dx. So that's basically saying we just took the derivative of an expression where x is the independent variable. Okay? Whereas on the left-hand side, when we took the derivative of u, we said that's really a 1 times du, which means we took the derivative where u was our independent variable. So we can just say that du is dx. So that means that in this particular problem, we'll be able to substitute and replace dx with du. And then notice that there is this additional x here that we're going to need to replace with a u somehow if we're going to meet our goal of rewriting this all in terms of u. Well, from this piece here, it's pretty easy to solve for x. We can see that x would just be u minus 1. So now let's do our substitution. So we know that in this x plus 2 piece, we know that x is the same as u minus 1. We still have that plus 2. And then the x plus 1 is just going to be referred to as u because that was our initial step here. We said u is x plus 1. That's going to be raised to the 6th power, and then my dx I'm going to replace with du. So notice how my goal has now been met. We have rewritten this all in terms of u. So now let's clean this up. All right, so from here we would have, this would be a u plus 1, and then times u to the 6th du. Alright, there's still more that I can do before I'm ready to take an integral. So we can distribute that u to the 6th, so I still have my integral symbol. So u to the 6th times u, that'd give me u to the 7th. And then we'd have, when we continue to distribute, you'd have a u to the 6th. Well, now what we're going to do is we are going to integrate this with respect to u. So u is our independent variable. So we're going to need our power rule here. So u to the 7th would become u to the 8th over 8. And then my u to the 6th, again, just using my power rule. All right, this is what we would have. And then our final step here, once we've done that, is to rewrite in terms of x. So we want to go back and get rid of the u's and put it back in terms of x, because the original problem was in terms of x. So we know that u is the same as x plus 1 from up above. So I would have x plus 1 to the 8th all over 8. So I'm just going to continue to substitute in x plus 1 where I see a u, and then this would be my final answer. Okay? Okay, let's look at one more example. This one's a little more complicated. So we can see that the inner function here is 2x plus 3. We're going to call that inner function u. And then we can see next to it that the diff certainly does not show up, right? The derivative of 2x plus 3 is 2. We have just a random x hanging out there, so we're nowhere near as having the derivative show up next to it. So that's why we need this technique called u substitution. So we let u be that inner function. Now, from there, it doesn't matter if you want to solve for x next or if you want to find the derivative of each side next. Let's do the derivative piece. So the derivative of u is just du. The derivative of 2x plus 3 is 2 with respect to x, so we say 2 dx. Okay. Now, remember, we're going to be looking to replace all of the x's with u's. So from this equation, if I am going to solve for dx, I would have to divide over that 2. So dx is going to be replaced with 1/2 du. All right, dx is equivalent to 1/2 du, or du divided by 2, however you want to express it. Okay, and then we're also going to need to get rid of this x that we see. So using my u equals 2x plus 3 from up above, we can solve for x by subtracting over 3 and then dividing by 2. So once we have found the u, the du, and then x, we are now able to substitute in and rewrite this all in terms of u. So we would have u to the 5th times our x, we said, is u minus 3 all over 2. And then the dx, we said, this time it's not just going to be replaced with a du. This time it's replaced with a 1/2 times du. So you can write it like that if you'd like. Now let's try to make our lives easier. Notice how we have this 1/2 times another 1/2. So we could actually take out a 1/4. All right, throw that out in front. And then we're left with u to the 5th times u minus 3. All right, with respect to u. So that du on the end indicates we're going to be looking to integrate with u as our independent variable. So you want to always look to pull out as much as possible. In this case, we pull out a 1/4, all right, to make simplifying much easier. Well, there's still more simplifying we can do before we're ready to integrate. So I can distribute my u to the 5th, so I'd have u to the 6th minus 3 u to the 5th du. Well, now I've done enough simplifying, and now I am ready to actually integrate. So this 1/4, I'm going to just bring that along for the ride. I'm going to just kind of ignore it until the very end. So I know I'm going to have a u to the 7 over 7 minus a 3 u to the 6th over 6. So I'm just doing my power rule again. All right, and then I can reduce this and turn it into a 1/2. So from there, I'm going to go ahead and now distribute my 1/4. So I'm going to have u to the 7th over 28. And then we're going to have minus a u to the 6th over 8. Right? Again, I reduce that 3 over 6 to 1/2. And then from there, our final step is to resubstitute. So u is 2x plus 3. So that would be raised to the 7th. And again, you can divide this all by 28, or you can multiply it by 1 over 28. However you prefer to write it is fine. If it's multiple choice, just pick out the one that matches, right? So then we have all of this plus c, and that would be our final answer.